ahead. All right. We still need to do a couple more inverse Laplace transforms. For example, how are you going to find y of t? How are you going to find y of t? Well, the problem is this. The problem is this is not a strictly proper rational function. Okay. By that I mean that's s to the 1 and this is s to the 1. So the highest power of s on the top is 1 and the highest power of s on the bottom is 1. This is called this is not a. How about now?
Still in and out.
Yeah, but I don't know if that's me or that's you. How many other people? Am I breaking up for everybody else?
Yeah, you was coming in earlier.
All right. Well, I can't help that. I don't know if that's me or that's you. Proper rational function, strictly proper rational function. So we have to do long division to make it proper. Okay. So this s to s goes 1. So s plus 4 minus 3. Therefore, excuse me?
Still doing the partial thing we was doing last class.
Young man, does that look that way now?
No, sir. I just asking.
Well, why don't you pay attention to what I'm doing? So s plus 1 divided by s plus 4 is equal to 1 minus 3 over s plus 4. Okay. So we use long division to create a proper. Now this is proper. This is a proper rational function. Okay. And so this is y of s. Okay. So y of t is going to be inverse Laplace of 1 minus inverse Laplace of 3 over 3 plus 4. What's the inverse Laplace of 1? What's the inverse Laplace of 1?
Yes.
The inverse Laplace of 1 cannot be s. You take the Laplace till you get s. What's the inverse Laplace of 1? This is y of t, not y of s. What is the inverse Laplace of 1? Okay, I see that you folks you're not learning You didn't learn the table like I asked you to. What is capital Y of t? Does that make any sense at all? There is no capital Y of t. We never talk about a capital Y of t. We talk about a capital Y of s.
What
This is the... Go ahead.
would the inverse of Laplace for 1 be s?
Somebody just said that and I told them no. Were you not listening?
Sorry, I didn't hear.
Inverse
No,
of
you weren't paying attention.
Laplace of 1 is 1 over s.
I didn't ask for the Laplace of 1. I asked for the inverse Laplace of 1. This is the inverse Laplace, not Laplace. The table I asked you to memorize, entry 1. This is entry 1.
Delta t.
Delta of t. Not delta t, delta of t. Delta of t, yes. The plus of delta of t is 1. The plus of delta of t is 1. Therefore, to go the other way, you have to take inverse Laplace. Therefore, inverse Laplace of 1 is delta of t. And what's the inverse Laplace of 3 over 3 plus 4? Sorry, that's supposed to be s. What's the inverse Laplace of 3 over 3 divided by f plus 4? Listen, the final exam is 2 weeks from Friday. No, the day is Friday. The final exam is 2 weeks from today. And you folks, I don't know when you intend to learn it.
Wouldn't that be 3e to the minus 2 t?
Where you get 2 from?
I was taking it for the 4. So just be 4. It was to be in the form out of 2 squared, no?
Miss Buchap, you are confusing. You're confusing 3 over s squared plus 4. This is not what I asked you for. You better get these things straight in your head before 2 weeks from today. Because as you can see, the final exam I sent you, that's heavily got to do with Laplace transforms.
Say it again.
All right. Say what again? All right.
You was talking about the final exam. I was saying if you could say it again because you was
The
breaking
final exam is 2 weeks. The final exam is 2 weeks from today. If you folks don't know what I've already taught you, when are you going to learn it? When are you going to learn it? Did you hear that?
Yes, sir.
Yeah.
All right. All right. My job is to teach, but your job is to learn. Learning is not a passive thing. You don't just show up to class and you learn. You have to be actively involved. You have to work these problems on your own. You have to learn the table. Let's do another example of this.
I can see that page right quick, please. All right, I got it. Thanks.
Problem with this. Mr. Johnson, you were saying something?
I'm saying there's a quadratic in the denominator.
Why is that a problem?
Don't we have the factor?
But that's not the problem yet. The problem is what I just told you about with the first example we did for the day. This power is s squared. This power is s squared. That's a problem. This is not a strictly proper rational function. Just like the last one. Okay. This power is 1, this power is 1. So again, not a strictly proper rational function. Division. Long division. All right. So this goes 1, s squared plus 3s plus 2. So that's s minus 2. Therefore, this now what do we have to do with this? Now you see this is proper. Because this power is 1, this power is 2. The numerator power, the highest numerator power is 1 less than the denominator highest power. So this is x of s. So x of t then, x of t is going to be inverse Laplace of 1 again, plus inverse Laplace of s minus 2 over s squared plus 3s plus 2. Okay. We already found out this is delta of t. Now what is this? Okay. What's s minus 2? How do we find inverse Laplace of this? What's the first step? Folks, we've already done this. What's the first step?
Because we start off by factorizing the denominator.
Which gives us what?
Plus
Um,
1 and s plus 2. Open bracket, s plus 1. S plus 2,
Now
yes.
what? Now what?
Could we use, remember
Now what?
partial, last class, but that's when you was covering your finger on one of the roots. And we did a over, for example,
Partial fraction expansion.
as a
Mr. Johnson learned the right term. Partial
partial
fraction expansion. So this is equal to what?
Wouldn't that be A over S plus 1 plus B over S plus 2?
Yes. And A equals what? What is A equal to?
that'd be s minus 2 over s plus 2.
That's it? That's the end of it?
Evaluate that, that's the long line, or when s equals -1.
Yes.
And then you plug in the -1 where you see s.
So that gives us -3 over 1, which is -3. So A is -3. Okay. And everybody get this? Because I have to go to the next page. Uh, what did we do last class? Young man, what did we do last class? Listen to me. If you do not study, you will not learn. So what's B equal to? What is B equal to?
S minus 2 over S plus 1. Evaluate at S minus 2.
Therefore, an inverse Laplace of this equals the inverse Laplace of this. Inverse Laplace of this. And what's the inverse Laplace of negative 3 over S plus 1? What's the inverse Laplace of this first one?
Negative 3e to the negative 1 to the negative t.
U of t, yes. And the second one?
That's 4e to the negative 2t, u of t.
Yes. So now x of t is equal to delta of t minus 3 e to the minus t u of t plus 4 e to the minus 2t u of t. Any questions about that?
What is that letter before delta t? Is that A or T?
The letter before delta t? What page you on? What page are you on?
I think you mean the one at the bottom, you know.
Supposed to be x.
This is x of t. Because our original function is x of s. And here's x of t right here. We got x of t right here. We evaluated this part, but we didn't evaluate that part. Anybody else? Okay, that's all the work I'm going to do on improper rational functions.
So, Dr.
Okay,
Gary,
the rest is
on the final exam paper, which question would that
yes.
fall under?
On what final exam
The paper that you
question?
sent us, you said you could review from.
Listen to me. I don't want you thinking everything I can test you on is on that final exam paper. Because that's not the truth. That's one example of what a final exam in ELT 320 can look like. But that does not mean I am limited to those questions. It is impossible to ask all the questions I can ask on any final exam.
But yeah, Doctor, but it may come. So we just trying to prepare, you know, just in case.
No. But the question you're asking me, is the question that person just asked is, where is that in the question on the final exam? And the fact of the matter is, I don't know because I can't remember the final exam. And secondly, it may not be there. But because it's not there on the last final exam, does not mean it won't be on this final exam. You are responsible for everything you learn. No, you are responsible for everything we do in class. Because half of you don't learn it. Time is running out. We have to move on. There are lots of questions in the textbook. Lots of questions. And if you haven't bought the textbook, that's on you. That's like a carpenter not buying a hammer. Now, let's look at this. Is this entering the table?
No, sir.
No, there isn't. What entry we have in the table? We have this. This is in the table. And the inverse Laplace of that is, so the inverse Laplace of this is t either. So now we're going to do partial fraction expansions again. But this, you see, this is the quadratic. What case is this? What case of quadratic is this? What case is this quadratic?
Real and equal.
Equal, yes. Real and equal, two roots. What are the two roots?
That'd be s minus 1. Negative 1 and negative 1.
Negative 1 and negative 1. Yes. And you can see that by doing what? Writing this out like this. S plus 1 all squared means s plus 1 times s plus 1. So this is case 2. We looked at case 1 for finding inverse Laplace. We looked at case 3 for finding inverse Laplace, but we have not yet looked at case 2. And we're doing that right now. We're doing that right now. So this becomes this is a quadratic. There are two factors, therefore expect two unknowns. So this would be a over s plus 1 squared plus b over s plus 1. Now notice how that differs from what we've done so far.
Dr. Cartwright, why different this time? Because I
what?
see you have that. No, never mind. I can let you explain it because I think he's about to explain it anyways.
You know, man, I already said what I had to say. Go ahead. What's your question?
No, I was saying that why look different from what we did last time, but then I remember this the impartial one. So
no, this is not the improper one. First of all, you got the name wrong. I never said anything about impartial. Never.
oh, My bad. Improper.
This is not improper. As a matter of fact, this is totally proper. Why is this totally proper? This is totally proper. Why? Or how do I know this is totally proper? Anybody? What's the highest power of x on the numerator? What's the highest power of x on the numerator? One. What's the highest power of x on the denominator?
2.
So does that
I didn't hear you for like 5 seconds.
make proper?
Oh God, ready break up.
Well, I don't know what to do about that. All right. Give me a couple of minutes to move to closer to the router. Let me see if that helps. So hang on for a few minutes. Students are planning. I keep breaking up. Okay, I'm back. Can you see my writing pad?
I can see it.
Okay, good. Let me briefly go over what I said before. The degree, this is the first question we did today. The degree of the numerator is equal to the degree of the denominator. This has power 1, this has power 1. Therefore, it is not a strictly proper rational function. And because it's not a strictly rational, proper rational function, we have to do long division to make it thus. So we turn this into this. The same is true of the second example we use. The second example, the highest power is 2 on the numerator, and the highest power is 2 on the denominator. So again, this is not a strictly proper rational function. So again, we have to use long division. Okay. Are you all hearing this?
Yes, sir.
All right. Good. Now, that brings us to the third example, which has nothing to do with the two previous examples, because this is strictly proper. Why? The degree of the numerator is 1, the degree of the denominator is 2. S times S is S squared. Okay. Therefore, it is a proper rational function. Therefore, we are not doing long division. We're doing partial fraction expansion. But we're doing partial fraction expansion that's a little bit different from what we've done before. Okay. We have to do something a little bit different because the two factors are the same. This is S plus 1 and this is S plus 1, but we can't write S plus 1 here and S plus 1 there. That's just like writing A plus B up here. So the rule is, this is the rule, just learn the rule. This rule says if you have repeated roots, that's what this is, repeated factors. If this was 3, if this was 3, then we would have A over S plus 1 cubed plus B over S plus 1 squared plus C over S plus 1. That's the rule. Any questions so far?
No, sir.
All right. So the question becomes, how do we determine A and B? Well, the book gives a very complicated way of doing it when you're just dealing with a quadratic. So I'm not going to go that way today. If we have time left in the semester, I may come back to this. I'm just going to show you a very simple way of doing it. Well, simpler anyway. Okay. The way the book does it is it involves multiple derivatives with respect to S. And I'm sure none of you want that.
So
go ahead.
I was asking, so that exam can't get pushed back.
No. I mean, it's not like y'all don't know. Y'all didn't know that the final exam was the last day of class. Y'all knew that from day one.
Graduating on the 23rd. That's like right now.
Yes, and you had all semester to think about that.
Come on, but you say you didn't even get through half the material. What you wanted to get through?
I did not say that. I did not say that, young man.
So
I said for the final exam. I said for last year's final exam. But who says this year's final exam got to be the same as last year's final exam? I'm not going to test you on something I don't teach you. But if I teach it to you, then you should know it. You see, what your mistake was, most of your mistake was, you think all y'all gonna learn this stuff the night before the exam. It ain't gonna happen. I've been telling you all semester, you must study, you must study, you must study. You ignored me. And now Judgment Day is upon us. And now you want to postpone Judgment Day, but you cannot postpone Judgment Day. It is here now.
Coach Judge, did we lose a day because of the snow?
You're killing me. Say Judgment Day.
Excuse me. We lost a day. That just means we lose that material that I could test you on. That's all that means. That doesn't mean the final exam has to be postponed. You are responsible for what I teach you up until Wednesday before that Friday with the final exam. That's what you're responsible for. And this is not news to you. This is true of every exam you ever took at UB.
I mean, at least for midterm, we had like a little break to study for it. With the midterm.
Yo, man, you can bitch all you want. The final exam is set.
No, I know, I just saying.
And you know you would have no time to study for it. Therefore, you should have been studying after every class. See, now some of you know just now getting serious. And you're realizing, damn, I should have been serious all semester. Well, that's on you, that ain't on me. You are adults and you behave like kindergarten kids, so you have to keep telling them, do this, do this, do this. Judgment Day is upon us. So you better pay attention to what we do for the rest of the time that we have. Getting back to my point. So we have this partial fraction expansion. This is partial fraction expansion when there are repeated roots. If you had been paying any attention, if you've been paying any attention to what we've been doing with partial fraction expansions, the rules are different. The rules are different depending on whether the roots are real and unequal, case one. Okay. The rules are complex conjugates. We did that already. And now the rules are equal and equal. Today's lesson. You should have already mastered the other two cases, which we did last class. The first one we did was case 3. And then last class we did case 1. Today we're doing case 2. Right now we're doing case 2. All right. So what we do is we multiply both sides by this denominator. So s over s squared plus 1, s plus 1 squared becomes just s. And that becomes a over s plus 1 squared plus b times s plus 1 squared over s plus 1. So clearly these two cancel. And this one cancels one of those. We're left with s equals a plus bs plus 1. That's what we're left with. And again, what did I call this? What did I call this? Nobody remembers because nobody studies. I call this an identity. And what did that mean? What did identity mean?
It'll always be true.
For all S values. So we have then S plus 0 equals A plus BS plus B. Or S plus 0 equals A plus B plus BS. So equating both sides, this coefficient is 1, this coefficient is B. So B must be 1. This coefficient is 0 because it wasn't there. 0 must be equal to A plus B. Okay, so 0 equals A must be negative B. Okay, so A is negative 1. So back up here then, this is negative 1 over S plus 1 squared plus 1 over S plus 1. And now let's check our answer. I'm going to another page, so if you need to copy that, please, you need to screen, you need to snip that, please go ahead and do it very quickly.
I have a question.
Yes, go ahead.
At S plus 0, that was at the first one. I see is that a BS?
Where did the BS come from?
I assume a new expand the brackets. Yeah.
So why are you asking this question then?
All right then.
Mr. Johnson, I can't for life figure out why you always ask obvious questions. All right, so let's check that then. Let us check. Let us add this together. Okay. So that goes into that 1 times negative 1 is negative 1. That goes into that S plus 1 times. So what are you left with? Left with S of S squared plus 1 squared. So that's a check. Our expansion is right. All right. So that rule works. And that's all we need to care about. All right, so now we got the inverse Laplace of this is the inverse Laplace of negative 1 over plus S plus 1 squared plus inverse Laplace of 1 over S plus 1. Okay. And now from the table, what is this equal to?
Would that be negative E to the power of negative T U of T.
Yeah, man. What entry are you looking at?
You should use entry 10.
All right. Let me find 310. This is actually T10, isn't it? This is T10. This is entry T10. T10 says this. T10 says this. Okay. E to the minus alpha T to the N equals Laplace of this, I should say, equals T to the N over S plus alpha. Sorry, equals N factorial, I should say. Okay. T to the N plus 1. So clearly, you'll see this better if we bring on the negative 1. Negative 1 inverse Laplace of 1 over S plus 1 squared. Right? I haven't changed anything, have I? This is the entry you want. Clearly, N is 1. You see that? N plus 1 is a power. So N plus 1 equals 2. Not only that, alpha is 1. Alpha is 1. So we have here what? E to the minus T. And then what? T to the power 1. That's what this is. And then, of course, you have to multiply by negative 1. Yeah, go ahead. Excuse me? No. No, look at it. Look at it. The power down here is N plus 1. What's the power here? So N plus 1 equals 2. So what is N? So this here in our case, N is 1. And if N is 1, then this becomes 1 factorial over S plus 1, okay, 2. And 1 factorial is 1 over S plus 1 squared. This is exactly what we have. So this first term here then is negative T e to the minus T. E to the power of negative T. U of T. And then the second one, what's the second one?
I'll just be e to the minus t.
E to the minus T U of T. Yes. Any questions about this?
So when you're writing the final t have to be to the front.
No, that's convention, but it doesn't have to be.
I could have just
A product is a product. The order of a product, it doesn't matter.
all right.
A B equals BA. Okay, let's do one more example. Okay, what's the expansion going to be? Somebody give me the expansion. Nobody can give me the expansion? Folks, how many factors do you have? How many factors do you have? Folks, first of all, please answer my question. How many factors do we have? I don't know why you all ignore my questions.
Three factors.
We have three factors. So how many coefficients we're gonna have? Three. Are A, B, and C. All right, now give me those factors. Give me those partial fractions. A, yes. Okay. Yes. That's one way of doing it. We could have put the S plus 2 first, and then have the S plus 3 squared second, and then the S plus 3 third. We could have done that as well. Now, here's the thing. The equation for C remains the same. The equation for C is what? Hide S plus 2, which is 1 over S plus 3 squared. Okay? Evaluate it at S equals negative 2, which gives us what? 1 divided by negative 2 plus 3 squared, which is 1. C is 1. Okay. And now multiply both sides. Multiply both sides. This is now 1, so I can put 1 there. Multiply both sides now by the denominator. So this becomes 1 equals A. Yes, go ahead.
Question: any particular reason why you used S plus 3 first, or you do it anyway?
Young man, didn't you just hear me say that the order didn't matter?
Oh, no, I didn't add up. All right, my bad.
Multiply both sides by the denominator. So this becomes Okay. So on this side, we have 0s squared plus 0s plus 1 equals, let's take that squares now, equals b plus 1 s squared. Okay, so that gets rid of that. I get rid of that. And now the s terms, what are the s terms? The s terms are what? A plus 5b, okay, plus 6 times s, okay, and then we have, okay, then we have a2 or 2a plus 6b plus 9. Okay. So clearly b plus 1 is 0. Okay. So that means what? B equals negative 1. Okay. Clearly this is 0. So a minus 5b, minus 5, because b is negative 1, plus 6 equals 0. Okay. So a is how much? A equals negative 1 also. And then we could further demonstrate that 2a will be negative 2, 6b would be negative 6 plus 9. That's 1. 1 equals 1. So this is then, this is negative 1 over s plus 3 squared plus b, negative 1 over s plus 3 plus 1 over s plus 2. Well, let me call this g of s. So g of t then, g of t is negative t e to the minus 3t. Negative e to the minus 3t. Negative e to the minus 2t. And all of that is times u of t. Any questions about that?
Is there a shorter method?
No. Well, you can do the book way, but the book way involves differentiation. You want to take the derivative of this with respect to s?
No, sir.
Well, that's what you have to do with the book way. All right. So it is not difficult. It may be tedious, but it's not difficult. All you're doing is multiplying and then multiplying brackets and then setting coefficients equal. The coefficient of s on both sides, s squared on both sides, the coefficient of s on both sides, and the coefficient of this is actually s to the 0. I hope you know that. This is actually s to the 0. 1 times s to the 0. So 2, 1, 0. But we don't normally write that, but that's what it is. Any other questions? Okay. Again, there are questions in the textbook that you could work on. Now, let's get to why we're doing all this. Let's do an example. Let's do an example that we know the answer to. What's V of t equal to? When the switch is closed, what's V of t equal to? V of t for t greater than or equals 0 plus. What's V of t equal to? So you all forgotten chapter 3 now. Well, folks, good luck to you all on the final exam. I mean, chapter 4. This is chapter 4. Nobody can tell me what V of t equals to?
Hold on. Yeah, give us a sec.
If it's greater than or equal to 0 plus, that should be 10. 10 volts.
Really? That's what we learned in chapter 4.
I have a question.
Yes,
So
Mr.
when we
Johnson?
up to
Oh no, hold on. Never mind.
When t greater than 0,
Mr. Johnson, you broke up. Please say again.
you say when t is greater than 0?
Greater than or equal to 0 plus. Yes, that's what I said.
Can I assume that we have an initial voltage or no?
Well, is any initial voltage given?
No. In that case, V of t is 0.
You, Mr. Johnson, that is so wrong. That is so wrong.
1 second.
All that work we did in chapter 4, and that's what you tell me? All right, I can't wait any longer. Please pay attention. V of t is V of infinity plus V of 0 plus minus V of infinity e to the minus t over tau volts. Now, what's V of infinity? What's V of infinity?
10 volts.
10 volts. And what's V of 0?
0.
0. This rings any bell? And what is tau?
RC.
And how much is that?
Mm. Okay.
You really need a calculator for that? That's 1. RC is 1. Okay. That's what we know from chapter 4. That's what we know from chapter 4. Now let's do this Laplace way.
And you say we get in the question of chapter 4 in the final check?
Yes. Yes, that's what I said. Last year it doesn't have a question from chapter 4. So now let's do this. By Laplace. What's Laplace of 10? I'm doing this with t greater than 0. What's Laplace for 10?
Ten over S.
10 over s. Thank you very much. 10 over s. Now this you won't know. What's Laplace of resistor? Just a resistor. Laplace of resistor is just a resistor. Okay. What's Laplace of the capacitor? Laplace of the capacitor is 1 over SC, just like it was for phases. Just like it was for phases. Okay. What's Laplace of V of t? V of s. So this is figure 1. Okay. This is figure 2. This is Laplace of figure 1. Okay. So this is just an impedance. That's an impedance. That's a Laplace impedance. There's also impedance when we use phases. Okay. So what's V of s equal to? What kind of circuit is this, folks? Oh, SC. C is 1 milli. So this would be 1,000 of S. This is an impedance. This is an impedance. 2 impedances in series. What kind of circuit is this? Young man, I asked what kind of circuit this is. I didn't ask when is the circuit valid. I asked what kind of circuit is this?
SCR.
What kind of circuit is this? Do better than that. Do better than that. Yes, it's a simple series circuit. This is a simple series circuit. But do better than that. It amazes me that we could teach students so much circuit analysis and they still don't know shit when you need them to answer the question. Just amazes me. It's a voltage divider circuit. It's a voltage divider circuit. Therefore, you can use what? The voltage divider rule. Give me the voltage divider rule for V. And this simple one down here. Give me the voltage divider rule.
You could say this voltage is.
Excuse me?
Now I'm asking what this is in front of E6.
Where you seeing V6? Where are you seeing V6? I'm looking at this bottom diagram here.
Yeah.
Where you see V6?
I'm asking if that's a 6 volts. So just V6, open bracket, R2 over R1 plus R2.
All right. That actually says 10 volts, but it doesn't matter. It's a principle that matters. So V is R2 over R1 plus R2 times 10. Now give me V of S. Give me V of S.
V of S, we could just say 1,000 over S over 1,000 plus 1,000 over S.
All right. That's it?
Times 10.
Times what? Times 10 over S. Thank you very much. Times 10 over S. So multiplying top and bottom by S, that's 1,000 over 1,000 S plus 1,000 times 10 over S. So dividing by 1,000, that's 1 over S plus 1 times 10 over S. So that's V of S. So how are you going to find V of T? How are you going to find V of T? Is somebody saying something? How are you going to find V of T?
Use Laplace.
No, use inverse Laplace.
And use Laplace.
Well, and how do we find the inverse Laplace of this?
You would have to make it into a proper fraction.
Now you're talking fool. Now you're talking fool. You don't think that's a proper? You don't think that's proper? What's the? Wait. Let me get Mr. Johnson here. What is the power of X on the numerator? Mr. Johnson, what's the power of S on the numerator?
1.
No, 0. You don't see any S here. S to the 1 is S. S to the 0 is 1. What's the power on the denominator? What's the power of S on the denominator?
1.
You talking fool, young man. You don't see S times S?
That's 2. S squared.
So you don't think this is proper?
It's proper.
I think sometimes your mouth works quicker than your brain. So what do we do with this? Anybody, what do we do with this? Excuse me? That's what I'm asking you to do. I'm asking you how you're going to find the inverse of this. Where are you getting that from? Young man, these two are being multiplied. They're being multiplied. They're not being added. I'm running out of time. Partial fraction expansion. Partial fraction expansion. Please give it to me. Yes? Of course. Why are you not sure of that? All right. What's A going to be equal to? What's A going to be equal to?
A equals 10 over S. Evaluate at -1.
-10. -10. What's B equal to?
That'll be
Excuse me?
10 over S plus 1.
You're not finished. Evaluated at?
Is S0?
S equals 0. The root of this is 0. So that's what? 10. So this is simply -10, 1 over S plus 1. Okay. Plus 10 over S. Therefore, V of t equals -10 e to the minus t. Plus what? 10. Okay. Volts. Is that not the same thing as we got from chapter 4? This is what we got from chapter 4.
Hey, Dr. Godwin, I didn't catch page 7.
Dr. Godred, we could use the same methods we use them from chapter 5 to solve problems in chapter 4.
Not if I say no. Not if I say do not use Laplace transforms.
Okay, but we could still use it like the double check.
You gonna have time to double check?
Hell no.
No, sir.
You think I would have taught you chapter 4 if I don't want you to know chapter 4?
No, sir.
Sorry, guy, you mind putting it back on page 8, please?
Let's consider this one now. I don't have time to do it today, but I want you to try it. I want you to try it. Instead of putting a battery here, same problem. You see, you don't know how to do this from chapter 4. Okay. Find V of t. Find V of t using Laplace transforms. Okay. So you have a lot of work cut out for you today. I don't have to give you any homework. You have homework. You need to learn the material that you should have learned by now, and clearly you don't. You haven't. You have to be sure you understand everything we did today. And then I want you to work on this for Monday. I don't want you to hand it in. I'm not going to grade it, but I want to see what you come up with. You should be able to come up with the correct answer.
Dr. God, you say we are or we aren't getting another homework?
I haven't decided yet.
All right.
Let me see my grades I got for you.
Sorry, guy, right?
Yes.
He asks us now if you given another homework.
Yes.
Okay.
Yes. I may give. Let me just see what I got here. Y'all can't see my screen, can you? I mean, besides my writing pad.
Those are,
Huh? It's on the writing pad, okay. All right, because I'm going to put some grades up here, and I don't want you to see anybody else's grades. All right, we're gonna do another test because I only got one test grade for you. We're gonna do another take-home test, and that's gonna be pretty soon.
So one more take-home test before the final.
Yes, at least one more. At least one more take-home test. Any other questions or concerns? All right, I hear none.